Hello everyone and welcome to today's webinar on true integration without synchronization with object-oriented technology for basic and detailed plant engineering with CADISON. My name is Krunal Sharma and I'll be presenting this session. I work as Technical Manager with Engineering Solutions Group at Neilsoft. In my past 10 years of being associated with CADISON Plant Design Solution, I had the privilege of helping large organizations to implement integrated plant design solution. I'm both excited and pleased to be sharing a lot of information regarding integrated plant design with you in this webinar. But firstly, today's webinar will be available on demand after the live session and will be accessible through a link that we will share with you. Also, you can visit our website www.cadison.com for many interesting webinars like this and other related content, including our CADISON World magazine and list of upcoming webinars as well. In this webinar, we will discuss how almost all plant engineering projects today face a challenging integrating different subdisciplines. This integration usually starts from a concept to basic and detailed engineering of the plant, which even extends to the handover of the as-built documentation and scheduling of service and maintenance intervals. CADISON solution is built around the object-oriented technology with modular architecture, enabling a model-based process of intelligent and integrated plant information modeling. This technology improves engineering efficiency by reducing data redundancy, maintaining up-to-date data for all users, real-time integration and communication between different disciplines, and automatic report generation at project level. With CADISON solution, different disciplines can seamlessly integrate by providing all information flows into a single central database repository, and all involved always have access to the latest engineering data in the project without complex synchronization mechanism. True integration in plant engineering massively reduces change costs and avoids potential sources of errors. Due to single central database repository, projects can be designed more efficiently and effectively, and with minimal risk of course. We will see all this with some examples from the software later on in this presentation. These examples include some real-life practical scenarios of integration. But before going further, let me tell you that we would love to hear from you during today's presentation. If you have any questions, please feel free to ask them after the session is completed through the questions tab or by getting in touch with us with our sales teams. I will be answering questions at the end of the session. If we don't get to your question during today's webinar, we will be sure to follow up afterwards. And last, we would like to encourage you to share today's webinar if you find it useful with your professional network, within your organization or in your circle. So without any further ado, I'd like to kick things off by introducing Neilsoft and ITF. Neilsoft is a 1,000+ people company with offices across metro cities in India and international presence in Europe and America. Neilsoft is a specialist engineering services and solutions provider, servicing clients across a range of engineering segments, helping improve their engineering efficiency, support their global footprint, and of course improve their competitiveness. Leveraging technology, domain knowledge, and our robust work planning methodology to ensure an effective global delivery model. We have emerged as a partner of choice for many leading Indian and international companies. While ITN Factory is a fully owned subsidiary of Neilsoft Group, is based out of Bad Sudan in Germany and has been developing process industry solutions from last 2 decades based on the object-oriented technology with a mission of improving engineering efficiency and focusing more on project workflow challenges such as real integration, change management, centralized documentation, real-time updates, unification of data graphics, instead of just managing information with a high-end database solution. Now, we come to the introduction of CADISON. In this wheel made out of jigsaw puzzle pieces, important CADISON offerings are listed. The quickest and the easiest to begin and implement is the basic engineering module that helps you create PNID and PFD with all associated deliverables. This intelligent or smart PNID is completely spec and rule driven. The three aspects that made this PNID designer intelligent are: 1. The database object for all graphics in the drawing, standard and company rule driven checks, and third and most important, accurate reporting. Also, engineering calculations like pipeline sizing, thickness and pressure drop calculations are completely inbuilt. Engineers can also do pump sizing and many electrical calculations like cable sizing and so on. The next module is the library or the catalog engine module of CADISON called MatPipe. This unique module of CADISON provides companies with piping standards and vendor catalog libraries for equipment and piping components. This module is also parametric, modular, that can build any custom object, and the sizes can be built later on with MS Excel export and import functionality. Pipe specifications for the piping designer are created here as well. Going further is our 3D design module called CADISON 3D Designer. CADISON 3D Designer is predominantly used for the space planning of piping layouts. This module is a single module that is used for creating equipments, pipelines, supports, basic steel. This module has interfaces to many other softwares, for example Caesar 2, RAW 2 for piping stress analysis. There is also a Navisworks Manage Export in the 3D Designer for the walkthrough of their plant. Apart from this, CADISON is also having 3D Designer is also having an interface with the Inventor, Autodesk Inventor software, so that equipments can be bought intelligently inside CADISON 3D Designer. Going ahead, there is an electrical designer. In this electrical designer, users can create single line diagrams, schematics, circuit diagram, 3D cable trays, panel layouts, and all associated reports, deliverables along with it. Inbuilt inside CADISON with all these modules is our report generator. This integrated report generator is very useful in creating customized reports. These reports can be lists, it can be BOM, data sheets, valve list, equipment list, and so on. To every 3D model, the other major requirement is the extraction of drawings. CADISON creates construction drawings, equipment layouts, piping GAs, isometrics right from the designer. Also, hookups from the piping supports are also possible that can be extracted. And finally, the ERP interface. The whole CADISON system is bidirectionally interfaced to ERP system. This can link procurement department with engineering. Now, since today's presentation webinar is on true integration really means data consistency. When we talk about true integration, we are essentially thinking about data consistency across multiple disciplines. While we know that design isn't a linear process, design of process and power plants constantly evolve and modifies as it iterates across multiple disciplines. These disciplines are teams like proposals, projects, process, piping, E&I, structural, and many others. As the design evolves, these teams must manage change by passing information among each other. They may have different working assumptions, different contractual deliveries, different goals, but the project, however, has one goal. It needs to be delivered on time, on budget, and to the highest standards. Taking control of the information exchange will achieve this, and that's why we have created an engineering design software that has integration at its core. While we call it integrated engineering and design, a robust yet flexible solution for controlling change, communicating change, and ensuring data consistency. Each discipline-specific product is part of a larger integrated solution and is naturally integrated on account of our object-oriented database, allowing critical design information to be shared between disciplines and across teams, so at any time they can access most up-to-date information they need to do their jobs. Now, how do we achieve this true integration? Or so to say, the data consistency with object-oriented technology. CADISON consists of object classes that contain objects. Each object can carry multiple representation or graphic within itself. This means one object but multiple graphics. For example, a valve available in PNID is when taken to 3D designer is represented with a 3D graphic over here. And when an isometric is created from the same valve is visualized as a valve ISO symbol. The same valve object carries multiple property groups that can also store data for creating reports like valve list, valve BOQ, valve datasheets, valve cost sheet, and with the help of custom attributes, other type of reports are possible as well. Objects are integrated in CADISON through simple drag and drop function that I will show you later on in this presentation. Objects are also intelligent to record changes they go through in the design lifecycle, and users also get critical notifications when these objects go through significant changes. The next and the most important functionality that is available to ensure that the true integration is in fact true and complete for all objects in the drawing, CADISON provides a graphical lookup to check the status of integration automatically. For example, users can see how many objects from a PNID are positioned in 3D with the help of color coding. All objects that are not placed yet can be highlighted as red in color in the PNID drawing itself. Now let's talk briefly about the object-oriented technology. Although the previous slides highlight the workflow and how the data consistency happens with the object-oriented technology, CADISON uses object-oriented technology at its core, unlike other tools for efficient plant engineering, because it not only stores and retrieves object data with all attributes in a structured manner, but also maintains all the relationships, inheritance of multidisciplinary objects and object classes being added. One common storage system, single object for graphic and engineering data, helps every project team member to work together in just one working environment simultaneously, delivering the latest updated information of the projects in all views across all disciplines in real time. This technology improves engineering efficiency by reducing data redundancy, maintaining up-to-date data for all users, real-time integration and communication between different disciplines, and automatic report generation at project level. It is possible to standardize, reuse, and even reconfigure relationship between objects as well as placement of objects. Now, plant information model. All this integration, true integration, later on helps you in building up the plant information model. CADISON helps in building a plant information model because it integrates engineering data, 2D and 3D design data into one managed plant information model, eliminating costly and damaging complexities. Companies using CADISON plant technology benefit from engineering and design savings of about 30% and more when compared to alternative solutions. These dramatic savings are made possible through a combined technology that with CADISON critical information is efficiently shared between disciplines and across teams, simplifying the process and improving project delivery. CADISON integrated plant design comprises of following core modules: the project engineer, the intelligent P&ID designer, 3D piping that includes pipe supports and steel layout, and finally electrical design. Now, these modules made for different disciplines and focus on specific deliverables, but all draw on information from each other and delivering one plant information model. CADISON supports true integration without complex synchronization workflows that I will show you later on. Communication between different design modules of CADISON is powered by the same database. And we are emphasizing on this one single database in all the modules. CADISON's integrated engineering and design makes it possible to support critical process in such a change, highlighting to identify and manage different versions of information. You can also work across disciplines at any point in a project with a powerful update capability. This allows users to easily control the synchronization of common engineering data between disciplines. Extremely resilient and flexible collaboration that is the backbone of creating your plant information module, enabling constantly accurate views of the data and the model. Now, I will show you certain examples about this true integration within CADISON. One of the functionality that we have is the simple drag and drop to integrate. In this example, we have the 3D designer module here. In this module, we have equipments and the pump foundations being placed. With the help of the CADISON database and the integration capability, the graphical integration, drag and drop, firstly, I will place the pumps from the CADISON tree that are available as a conceptual project from project engineer directly into the CADISON 3D design. And this can be done by dragging the pump from the CADISON tree to the drawing. In this next part, I will open the CADISON P&ID along with the CADISON 3D designer. A lot of our users use multiple monitor for doing this workflow. In this workflow, a CADISON P&ID is opened up, and in this CADISON P&ID we have some equipments and pumps. A catalog, a vendor catalog is attached to this pump symbol, and when this pump is taken to CADISON 3D designer, it can be placed as a 3D representation. This shows that CADISON provides a very simple drag and drop integration of objects from P&ID to 3D or vice versa as well, from 3D to P&ID also. Let's see our next example. Give me a moment. In our next example, this example is the integrated data modification. Now, if you have true integration, you have integration between objects in different drawings. You also need the data modification option so that when you change the information on one object, it changes the information throughout the disciplines. In this example, I have a P&ID drawing. In this P&ID drawing, I have a valve with a tag MV27. And The same valve is available in the 3D drawing, and the tag here is tagged as MV27 as well. The same valve is also available in the isometric. In the isometric and the valve BOQ as well. Now let's start this modification process by changing the code character of this valve from MV to MBV. When we change, the new tag number is MBV027. When I come to 3D, then this tag number is automatically updated. If I go to the layouts, the tag number is updated automatically. And to update the reports, I can update the report with a revision or without a revision. It gives me the flexibility of doing it both ways. And now after the update, I don't need to create a new BOQ, but the same BOQ can be updated and the tag number is also updated in the report. This shows that CADISON provides a true integration so that the modifications done on one level can also be automatically communicated to the other drawings and deliverables as well. And here you see that the isometric is now also updated with the MBV0027, and a new revision is created for this isometric. So now you can see that the integration is seamless from PNID to 3D to layouts to reports and finally to the isometrics. And now the revision of this drawing is also carried on after making this change, and the new revision is updated. Any revision done on a CADISON drawing creates a new copy, while the previous revision is superseded. Let's see another example of true integration, and in this example, the most important functionality from CADISON to check the integration, and we call this as interactive integration graphical check. In this example, we have a PNID and a 3D, and you can see that the same PNID scheme is constructed in 3D in the 3D designer. Now the user has carried out this project keeping in mind the integration between these two disciplines. But user also have a possibility of checking this integration with a single button. This is called graphical drawing synchronization. On one side you can select the PNID drawing, or you can select the flow diagram, you can select any drawing type, and on the second side you can also select the drawing type. And you can create a color code configuration for showing the missing objects. Now I'm checking the integration between the PNID and the dispositional drawing plant layout, that is the 3D drawing. And once I run this check, you see all these objects that are not integrated or that are not placed in the 3D that are being highlighted. You can also run the graphical check vice versa. You can also find out all these objects from 3D which are not there in PNID, or right now it's checking the objects which are in PNID but not there in 3D. If you find such objects, you can directly take these objects from the PNID, drag them in 3D and then place them on the line directly. So now we see here that the valve 002, D002 was not available, the C003 is also not available, and once it's been found out, user can just directly go on the valve, drag and drop them in 3D and place these objects in 3D. And now if the synchronization is run again, so it's a real-time synchronization run, the check, so you see that the valves have turned green. It means that the objects are now placed in the 3D design. This graphical check is very useful for doing such kind of integrated projects within CADISON. The next functionality, that is called Extensible Construction Set, also brings standardization through integration. While maintaining integration, users can also achieve standardization in their project. I have here a standard scheme of PNID, 3D, and a circuit diagram, that is an electrical diagram from a motor. User can see this information on each object. When you right click the object, you can see the object edit window, and inside this object edit window you can see that this object is integrated to the three different disciplines. So I have this scheme which is a standard scheme, and while creating this scheme I have maintained the integration between the PNID and the 3D, and then the motor is integrated to the diagram. I can save this entire assembly as a construction set. So the CADISON terminology of assembly is the construction set, and then when this construction set is placed, so it's saved and then it's placed again in the PNID, then the extended part of it, it is a 3D. So now this assembly is highlighted, that was placed again. The extended part of it is now available inside this construction set. So when the user drags it from the CADISON tree, you see that the 3D model of this scheme which was integrated to PNID is now placed in the 3D designer. This means that users or companies can keep integrated standard designs in the construction set object of the object manager, and then every time such standard packages are required, it can be directly dragged and dropped from the object manager of the CADISON designer. This is a very interesting functionality for the companies who work mostly with standards. But it's not just the standards where it's as simple as an AutoCAD block, but it's a completely intelligent assembly because it is also integrated to a different graphic type. The next, and again it's associated with the design, that is the change management. So integration in change management. So how integration helps in change management? Now in this case, I have a valve which is placed in the PNID, and the same valve is placed in 3D. This is at the moment a globe valve symbol and a globe valve representation in 3D. Now during the course of the project, in a lot of your designs you will always have changes. Now in this case, the change is that the valve type is now changed from globe valve to gate valve. The user wants to make this modification on the PNID. Now when he tries to modify this object, the system, so first of all the system gives information that the object is placed in PNID and 3D. When the user can modify the symbol to a globe valve, from globe valve, gate valve to globe valve, and now when it tries to modify the object type, CADISON designer provides a notification that the object is already placed. It means the user who have permissions to make these changes, they see a notification that the object is already placed and you are reintegrating this whole scheme. But in this case, I want to accept this change, and I am now ready to accept the new valve type. And once this change is made, the new catalog is attached, and as soon as the user jumps in the 3D designer, you will see that the valve graphic has updated automatically. And since it's an object-oriented database, if you access the object type, you see that the completely new information is now available from the catalog that was placed. In this way, you can handle object changes or any kind of changes that happens from PNID to 3D or 3D to PNID. A similar example for a pump as well. In the next example, which is related to the integrated change management, since I have shown you a lot of this integration through the graphics, the most important in case of change management is also the data, and how CADISON takes care of this integrated data that is available in your drawings. In this case, I have a PNID drawing, and in this PNID drawing I have different objects wherein the information is completely filled in related to the vendor, related to the operating parameters, and so on. Now any CADISON drawing can be edited also in terms of graphics, but when you edit these drawings, you will be able to open a complete Excel-like table that is shown here below, and in this table users can filter out objects. Now I have filtered out the object type called ball wall. In this table you can also modify the information or properties that are there. So the manufacturer is not given at the moment. I'm giving the manufacturer as GF, and I'm also defining a new type for this, and the type is 546. Now these changes once made here in the table will get directly updated in the drawing if this drawing is tagged with a similar property, but in case we have now changed the manufacturer and the type, this can only be highlighted in the reports. So as soon as the change is made and we update the reports with the revision text, so at the moment I have changed the manufacturer information and a new report is created very quickly. CADISON can create reports in Word and Excel, and now you see that the type and the manufacturer are now updated in the report. A similar behavior like the previous example happens in case of 3D Designer, where the information changed in the PNID is also carried on to 3D. CADISON also has a very robust revision management system wherein the changes are recorded on each level and the drawing can create a revision, but the users will always be available with the latest working copy. With this, I would like to thank you for attending this webinar, and if you have any questions, you can ask them now by filling out this information, filling out your questions in the questions tab, and I can answer them. So please go ahead and type your questions. For the next 10 minutes, I can answer these questions if you have any. You can post the questions in the questions tab. I'm online with you and I'm waiting for your questions. Do ask me questions related to the integration capabilities that I have shown you, or any other questions related to CADISON that you would like to ask. Okay, so we have got the first question here. Okay, so the first question here is, could you please address WBS related changes which are usual from proposal stage to actual design stage, how it works? Well, CADISON has some project specific attributes which are stored on the project level, and the WBS information is also recorded on the project level, but in case of the proposal it works a bit differently. I think we would like to give you an elaborated answer for this, and maybe we can discuss it offline so that we can explain you how the complete proposal engineering inside CADISON, how it works. The second question that I have is, we wish to extract BOM and drawings accordingly to modules. Well, to answer this, yes, if you create PNIDs in PNID Designer, you will be able to extract some of the BOQs, for example, the valve BOQs, miscellaneous items, and the PNID drawing is actually constructed in CADISON, can be exported to a .dwg file. While in case of 3D models, you will be able to extract a complete piping BOQ from the CADISON system, and the drawings that can be extracted are the piping GA drawings and isometrics and so on. Just go to the next question. Yes, so I have two questions. I request the audience, if they have more questions, they can ask me. So the next question that I have is, where I get video of basic tutorial of CADISON. Yes, you can get in touch with our sales team or our hotline, and you can ask for this tutorial. We have a very good basic tutorial documentation that takes care of the entire working philosophy of CADISON. I don't know if you're an existing customer or a new customer from CADISON, but yes, you can get this tutorial by connecting to our hotline. We have module specific tutorials available with us. Okay. The next question is, can we define a volume definition in 3D model and extract complete BOQs and construction quantities? Well, the answer for this is yes, but in this case maybe it's some kind of customization that can get added, and with this you will be able to extract the volumes. In some of the objects inside CADISON, yes, you have the volumes as default and you can extract the quantities from that. So please send us the tutorial. Yes, I think once you ask this question, so I have your email ID with me, so I'll ask the sales team, the backend team, to contact you and send you the information which is required. So the tutorials will be given to you, don't worry. The next question that I have here is, can we integrate PDMS data to CADISON? Well, the interoperability between plant design softwares is at the moment not that robust. So from CADISON you can give a dumb model to PDMS, and the same way, so from PDMS you can get a dumb model inside CADISON, but that would be just bringing in the graphics, so it would not be an intelligent integration as such. In case of smart plant, you can achieve this by the tool that they have called the smart plant interoperability, but between PDMS and CADISON it would be just exchange of graphics. It will be so the answer for this would be that no, there is no ready-made integration between PDMS and CADISON. So this question I have already answered. The next question is, could you please highlight sequence of integration required between CADISON repository and ERP software stepwise efforts? So yes, we have a detailed workflow with us that how CADISON system can be integrated to ERP, and it's a bi-directional interface that we have. And this happens predominantly through our module called CADISON Project Engineer. And if you get connected with us offline, then later on we can also show you, because these steps are will take some time to elaborate, and we can actually give you more information that how stepwise this complete CADISON system can get integrated to your ERP system. So please let's get in touch later on so that I can answer you these questions in detail. So how to get integration management table? It's a very good question to ask, because normally when such kind of integrated projects are made, so I've shown you the visual check, but the users also want to know maybe in a report, in a table report, so that how this is there any misalignment, or how is the integration okay or not. So yes, you can actually create an integration report. This you can do it in Excel. This is possible. You can create a report. For example, you can have a report wherein the valves that I've shown you, these valves are placed in PNID, 3D, isometric, data sheets, reports, BOQs or not. And if the object is not available in any of these documents, then you can find out that the information is not there in the report. So yes, you can create an integration management table. It's possible to do it. Good question. So next question I have is, please send me integration aspects and steps involved with the live demo. So yes, again for this question, or I'd say request, we will get in touch with you, because the live demo would take about an hour, and in this case we can show you the detailed presentation. So this webinar was only specifically to highlight our integration capabilities. But yes, in the overall system, it's a very vast system. There are so many functionalities in each of modules, and you can get the live demo from us. The integration aspects, yes, the integration aspects, some of them I've already covered in this webinar, but the more integration aspects can be covered, or maybe it can tell you in this demonstration that can be done on your site. You can also get in touch with us with email, so that we can send you more documented information about what you're asking. Is clash management and reporting exists? So yes, we have a clash management in our system, and from this clash manager you can also extract a report. But also, since Navisworks manages a universal platform for doing clash detections and reporting, we also have added a Navisworks export in our CADISON 3D designer, so that you can export the model in Navisworks and then do the clash management over there. But yes, within CADISON system it also exists. We can give you more information about this since you asked this question. Can you maintain multiple item code directories? Yes, we can do it. So again, it's a good question. I would say we can have multiple item codes. So for example, our objects have a tagging system inside them, and an object can carry more than one tagging system. So in this case, what I was showing you, there was a standard tagging system from CADISON, but yes, we can have more than that tagging system in each of these objects. And we can store information in our objects in the form of object manager library, or we can also store it through our MatPipe catalogs. So yes, it's possible. Again, this question needs elaboration, and our answer also needs elaboration. So for this we can get in touch with you, but again, a good question. Yeah, the answer is yes, in this case, positive. So I cannot understand this question, but it's regarding licensor, owner, EPC contractor. Well, maybe what I understand from this is, I can tell you that the software is a solution, CADISON solution, and it's applicable to owner operators, EPC contractors, consultants. So we have different modules, and these modules are applicable to different types of companies. So our existing customer base is also like that. So we have customers from different domains. They use our software. Now, maybe if you elaborate this question, if I have not answered it correctly, I can give you the answer as well. We have few more questions, I think. So yes, I can answer some of them. To have multiple good. So again, I don't know, could not understand it. Maybe if you elaborate it, and you'll be able to answer it. Item codes are different nomenclatures. So what I understand from this question is related to the tagging system. So the answer that I gave you was is related to the multiple tagging systems that we can build in our objects, and also the part where we can actually store multiple attributes like this from our catalog, and the new attributes can also be added. So yes, we can store such information. So with this, I would like to thank you all for taking time out from your busy schedule and attending this webinar. I hope this webinar was helpful in understanding the integration philosophy from CADISON, and in general in case of plant design. If you have more questions, you can get in touch with us. So through Arunabha, or you can get in touch with our sales teams, and we would like to come and show you the software, the complete live demonstration of the software, and in this case we will be able to happy to answer all of your questions. So once again, thank you very much for attending. Bye for now. Thank you.
Thank you all for attending the webinar.